Okay, next discussion is limits. And here we have some limit statements, and I want us to be able to read these correctly. So if I were to state this in words, I would say the limit as x approaches, and that's an important thing about limits, is that the x value is only getting close to 4. The limit as x approaches 4 of f of x is pi. Okay, so that's how I'd read that. Now, what does that mean? That means that as x gets close to 4, y gets close to pi. So that's the meaning of that. That's how you read it, and that's what it means. Now, we're getting close to 4. Down here, it looks like we're getting close to 7. And this is, and I'm not going to write the green statement here, this is the limit as x approaches 7 from the right. Okay, I've specified that we are approaching 7 from a particular side. Now up here, we didn't specify where we were approaching 4 from. Here we are approaching 4 from both sides. Here we are approaching 7 from the positive side, or from the right side of 7. So I'm going to write the meaning of this in red as x gets close to 7 from the right, y gets close to negative 12. Now, as x gets close to 7 from the left side, I don't have any information. I have no idea what the y value is doing. Now here we're going to guess the value of the limit, if it exists, by evaluating the function at given numbers. So we're going to kind of try to calculate what we believe the limit as x approaches negative 5 is. So your job, and we're going to press pause here, is to put these x values into this function right here. Now, if we actually put negative 5 in there, I do believe that we would get 0 over 0. Am I right about that? 25. Yeah. However, we're only getting close to negative 5, so we're going to avoid the whole 0 over 0 thing by only getting close. Plug those numbers in and figure out what the y value is, and then come on back. All right, those are the values of the function that I got at those particular x values. Now, if we're approaching negative 5, I guess I'm going to focus my attention on these guys right here, which are very close to negative 5. The closer and closer and closer x gets to negative 5, the closer this number gets to, looks like 5. And even if I'm approaching from the other way, the closer these values get to negative 5, the closer these values get to 5. So I'd say, I'd estimate that the limit, my guess, that the limit is 5. So that's a way we can use a table and kind of creep in from the left, creep in from the right. All right, let's have a visual representation of a function. Let's figure out what some of these limits are. Remember, a limit, we're only approaching. What's the limit as x approaches 2 from the negative side? Well, 2 is this red line right here. So if I'm approaching from the negative side, it looks like that y value that I'm approaching is 3. But approach that red line from the right side. Looks like I'm coming in on this road. Looks like the y value there is only 1. And f of 2, what is the value of the function? I guess I don't even have a dot there. F of 2 does not exist. So what is the limit as x approaches 2? Well, it depends on if I'm coming in from the right or coming in from the left. But since these things don't agree, I'd have to say that my limit does not exist. I'm not concerned about what's going on at 2. I'm only approaching 2. But I got to approach from both sides unless it specifies which side to approach from. This doesn't specify. I'm coming in from both sides and they don't agree with each other. So that limit doesn't exist. Now what about if I'm approaching 5 from the negative side? And if that negative wasn't there, make sure you put that in there. If I'm approaching 5 from the negative side, I think I'm getting a y value of 2. If I'm approaching 5 from the positive side, I think that I am again approaching a y value of 2. Now at 5, if I actually get to 5, the value of the function at 5 is 1. So what's the limit? Well, limit is, again, refers to only approaching 5. And as I approach from the right and the left, because it doesn't specify anything different, those numbers do agree. I am approaching 2, and that is the limit as I get really close to 5. So a limit exists at an x value of a when the limit as x approaches a from the left of this function involving x is equal to the limit as x approaches a from the right of that same function. And that's when a limit exists. That's when we get a number like 2. And if those numbers don't agree with each other, we just say limit doesn't exist. Now let's graph a function. And if we're going to graph this function, we got to be ready with an eraser. Limit as x approaches 2 from the negative side is 3. Well, here's 2. I got to approach from the negative side, and when I do, I'm going to get 3. Open dot there. And it shows some kind of a squiggly leading in there. Now, the longer the squiggly, the more erasing you're probably going to have to do. The limit as x approaches 2 from the right side is negative 1. So I guess I'm approaching a y value of negative 1 if I'm coming in from here. Oh, that wasn't very fun. Let's get a little wild and crazy here. Oh boy, that's good. Okay, f of 2 is 0, solid dot. The value of the function when x is 2 is 0. Now, what's the limit as x approaches negative 3? Now, coming into negative 3 from both sides, I'm going to get 2. Well, kind of a coincidence that I actually went through there. Wow, that's really a coincidence. All right. I got to have an open dot there. I got to have an open dot. I couldn't do that again in a million years. I got to have an open dot at 2. As x approaches negative 3, didn't specify which side, so it's coming in from both sides. I'm going to get a y value of 2. Now, leave your graph like this. This is looking good. But if I hadn't gotten lucky before, if I had drawn something that looked like this, and now I've got to put this on here. I've got to have my open dot here, and I got this, and I got this. Hey, this isn't a function. I got problems out here if I were to draw a vertical line. And so what I would have had to have done is that's when I would have had to grab my eraser. So hang on here. I've got to make sure that as I approach 2 from the left, I'm hitting that dot. As I'm approaching -3 from the right, I'm hitting that dot. And that I still have a function by not violating that vertical line test. F of -3 is 1, solid dot. So that's how I would draw this function. Be ready to use your eraser. All right, we move on to the last side. We're not going to define vertical asymptote right yet. We're going to look over here at this function. And what are the equations of the vertical asymptotes? Equations of vertical asymptotes. Let's see. It looks like we got a vertical asymptote over here at 4. So I'm going to say, now if that's a vertical line, it has an equation. Better have an equal sign when you are asked for an equation. X equals 4. Looks like we got another one right here at x equals -3. Looks like we're approaching those x values but never really getting there. Let's find the following limits. What is the limit as x approaches -3? And it must be from both sides because we haven't specified any differently. Well, let's see. If I'm approaching -3 from the right, it looks like I'm shooting all the way up to infinity, doesn't it? But if I'm approaching -3 from the left, I'm going to -infinity. And those guys don't agree. And therefore, this limit does not exist. Now, what's the limit as x approaches 4? Well, if I approach 4 from the left, it looks like I'm going up, 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 up to infinity. If I approach 4 from the right, I'm going up, 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 up to infinity. And those agree. Even though I can't give it a definite numerical value, they're both going to infinity. So that's what I'm going to say the limit is. Now, what is a vertical asymptote? Well, both of those are vertical asymptotes at -3 and at 4. Because the limit, oh, and I'm going to just add this. Definition of vertical asymptote at x equals, and let's call it a. The limit as x approaches a from the left of this function that involves an x either has to be infinity or it's got to be -infinity. So I'm going to say positive or -infinity. And that's my explanation of why there's a vertical asymptote at -3. I could just say because the limit as x approaches -3, the limit as x approaches -3 from the left is -infinity. Done. I've explained why. Or I could have said the limit as x approaches -3 from the right is positive infinity, and I'd be done. I only have to make one statement. Now, I could have said, oh boy, this is jumpy. I could have said the limit as x approaches a on the right side of f of x is infinity. Or maybe it would be -infinity. So it's either positive or it's -infinity. So why is there a vertical asymptote at 4? Because I could just make one statement. The limit as x approaches 4 from the right is infinity. And I'm done. Or I could have said the limit as x approaches 4 from the left equals infinity. So just show one side or the other approaches either infinity or negative infinity. Okay? So that is a nice introduction to limits.